right, guys, let's communicate with algebra. Let's look at terms. A term has a coefficient, a number in the front, and a variable. So you have a number and a letter, or a bunch of letters. This is the number in the front is going to be called your coefficient, and the stuff in the back here, x's and y's and whatnot, are your variables. If you don't have a variable, it's just a plain old number. So if you just have like 3 is called a constant. So constant, coefficient, variable. Coefficient and variable make a term. A constant is by itself. It's also a term though. Okay, so you could have a term of 3, or you could have one with a variable. So when we go through these real quick, like this guy right here, what's the coefficient in front of this guy? It's -3. Okay, so that's your coefficient. And then your variables are x and y. You could write x and y squared. The variables themselves are the letters, but you could also talk about how they're raised to power. We'll talk more about that later. If there is a negative, the negative goes with the coefficient. So the -3 is here. If the number is by itself, it's not a coefficient, it's not a variable, it's a constant. Okay, and that is that really. Oh, and also if there's nothing in front of a variable, it has a coefficient of 1. So if I had x, that's 1x. So 1 goes here. Okay, that's your coefficient. If you have a couple terms, they're separated by positives and negatives, or pluses and minuses, you make a polynomial. So you have different terms separated by an addition or a subtraction sign. And if that's the case, you have a polynomial, and there are special names for polynomials of different sizes. If you have one term, it's called a monomial. 2 terms, bi, 3 tri, and anything over 3, we just stop trying and we call them polynomials. And that's what they're called. We then move on to what's called the degree of a term. So the degree of the term is the power of the exponent. So here we have 3x to the 4. This guy here would have a degree of 4. This guy here would have a degree of 3, 2, etc. If there's more than one variable, you're going to add the individual powers together. So for example, here I got x to the 7 y squared. This is one term, right? So I have my coefficient of 5, my variables of x and y, raised to the 7 and the 2. You'll add those together to get 9, to get the degree. Okay, so this one's easier, right? There's a 3, it's 3. That's implied 1. This guy here with nothing has a 0. If you have a 2 and then an implied 1, you add them together to get 3. Okay, so that's called a degree. Why does it matter? It matters later on when we talk about degrees of polynomials. So when we get to degrees of polynomials, the degree determines the properties of the expression. So for example, y equals, and then if you have something like x squared, y equals x squared, or anything squared is going to look like this. So that's what you do in grade 10. In grade 9, we're going to look at degree of 1 equations, and there are straight lines. Later on, you can get the cubed, and then keep going and going and going. And then if you get to grade 12 math, you can do things like this, and you'll be able to graph this, sketch it. Anyway, degrees of polynomials, I kind of mentioned that. It's the degree of, it's the equal to the degree of the highest degreed term. That was horribly said. But what you do is you look through each term here, and you see which guy has the biggest degree. That guy wins, and that's the degree of the term, of the polynomial, sorry. So this guy has a degree of 2, this guy has a degree of 1, this guy has a degree of 0. This guy's the biggest, therefore he wins. The degree of the polynomial is 2. You get a 5 and a 1, that'll get you 6. Again, remember that y, just y by itself is y to the 1, same thing. So 5 plus 1 is 6, 3 and 4 is 7. This guy's bigger, this guy wins. The degree of the polynomial is 7. Let's apply some polynomials. So we'll do some word problems here. And what we're looking at here is this woman, Sandra, is going to make some money. And she's doing that by selling and buying, selling and buying. She's giving children and adult lessons of golf. So she gets $125. The place she works at gives her $125, and then $20 for each children's lesson and $30 for each adult lesson. So we'll go through here and we'll try to figure out how much money she makes in total, and that's more for later, but now we'll just mess around with coming up with equations. So when you do equations, I'm sure you did this in elementary school, you have to define the equations, and what we're going to do is go through everything here, and then every time some sort of variable will come up here, we have to define it. So we're going to look at how many children's lessons she gives and how many adult lessons she gives, and then we're going to figure out the total amount of money. So we probably should have started with T here, but it doesn't matter. We'll start with C. So we're going to figure out how many children's lessons she gives later, and what we'll do is we have to define that variable. So we let C represent the number of children's lessons. And then underneath here, if you keep it nice and lined up here, you can just use these jot marks. Right? These jot marks mean the same thing. So instead of writing represents the number of, you can just go jot mark, jot mark, jot mark. Very efficient. So we let A represent the number of adult lessons and let T be the total number of earnings. And if there's a unit, we'd like to put the unit here also. So that's in dollars. So if she was working, she would make a total amount of $125 because we said she makes 125, and then 20 times the children's lessons and 30 times the adult lessons. We'll spend more time with this later. But if she had 8 lessons for children and 6 lessons for adult, what did she earn? Well, 125 plus 20 times 8 plus 30 times 6. You're going to sub those in. So A is 6. So sub in A equals 6. Yes, A equals 6, and C equals 8. So I have these kind of in backwards order here. So I could have put C equals 8 and A equals 6. It doesn't matter. But sub them in the right spot. 8 children lessons go here. 6 go here. And multiply and add. So that's what she earns. Okay, so that's the word problems, which are great. And then we'll just finish up with this collecting like terms. Collecting like terms have the same variables to the same power. So like terms have the exact same letters to the exact same exponent. So for example, x and x are like terms, x squared and x squared are like terms. The number in front doesn't matter. It'll matter in a second, but it doesn't matter as far as if they're like or not. And these guys here, y and y squared, they're not the same. Okay, they're similar, right? Because they both have y's in them. But this guy is different than this guy. They're not like terms, or they're called unlike terms. A b and an ab, not the same, right? X, y, and yx, they are the same. Okay, I put a there. But they're the same because they're just written in a different order. So if you have xy and yx, they're the same thing. They're just written in a different order. So you can rearrange them. We usually go in alphabetical order, right? So you wouldn't see yx much. You'd see xy. This guy here, x squared y cubed. Let me just go carefully on this. And x squared y cubed, same letter to the same power. So there's a squared on the x, a squared on the x. Yep. Cubed on the y, a cubed on the y. Yep. So they're the same. They would not be the same. So this guy here, let's say I had this, x squared y cubed and and then x cubed y squared. X squared, x cubed, different. Even though there's a 3 and a 2, they're different. So unlike. Why does it matter? Because you can, that's not the good part. The good part is this. You can simplify by adding and subtracting. So basically, we're looking at things like this. I got the same thing written a few times, and I want to put them together. So I might have done this in class. I probably did it. I did it right here. So if you had 9 bananas, 7 apples, and 1 pear. So here's an example. 6 bananas, 3 apples, 4 apples, 1 pear, 3 bananas. You look down in a bag, you got a bunch of fruit in the bag, and you want to figure out what do you have total, how many bananas, how many apples, how many pears. What you're going to do is you're going to collect like terms. So I have 6 bananas and 3 bananas. I have 9 bananas. I got 3 apples, 4 apples. I got 7 apples, and I just have the 1 pear, so I have 1 pear. Stop there, okay? I know you would go, well, I got 17 pieces of fruit. That's fine. But we're talking about comparing bananas to apples here. It's a bit of a math joke. Okay, so once you collect terms like this, you stop. When you collect them, you can rewrite them in order, rearrange the terms into groups or identify like terms. I don't like to rearrange them. I like to circle. I probably told you that in class. So I have 3x squared and minus 2x squared here. So just be careful with that negative, right? So 3x squared and minus 2x squared. Then you have your y's. So you want to identify the terms and then collect them. Okay. So there's 3 and there's minus 2. 3 minus 2 is 1x squared. Then you have your y's. You had plus y plus 2y is plus 3y. And then you just have your constants at the back here, minus 9. If you want to rearrange, go ahead. there's nothing wrong with it. Just the reason I don't like it as much is that you can often make a mistake. So you go to rewrite this and you go 3x squared and then you go minus 2x squared and then you forget the minus or you forget the 2 or something like that and then you mess up. But it's totally up to you. This one here I rearranged, put the b's together, put the constants together, and you just figure out how much of each you have. All right, so let's get down to C. Remember that BA is the same as AB. So I got 3 ABs. And I got 5 ABs. What's going on with my pen? So together I have, oh sorry, and then I also have minus 4 ABs. My pen's throwing me off here. 3 and 5 is 8, minus 4 is 4, so I get 4 ABs, and then the constants 7 and minus 2 equal 5. Just be careful with a question like this, that you're aware that it's kind of similar variables here, but they're not like terms. Okay, they have to be the exact same. And that's it. Okay, so collecting like terms, coefficients, constants, variables, lots of fun. Take care.